Hello everybody. We have studied in a previous video about trigonometric ratios: sine, cosine, tangent, cosecant, secant, cotangent. In this lesson we will study about trigonometric ratios of some specific angles such as 30 degrees, 60 degrees, 90 degrees, 45 degrees, 0 degrees. So let us see what are the values of these specific angles. Welcome to the lesson. Let's try to figure out what are the trigonometric ratios of 45 degrees. Let us consider the triangle ABC, 90 degrees at B. Angle A is 45 degrees. So what will angle C be? Angle C will also be 45 degrees. And we know that in a triangle, if two angles are equal, the sides opposite to those angles are also equal. So let's consider the length AB to be equal to A. What will be the length BC? It will also be A. Can we figure out using Pythagoras theorem what will be AC? So according to Pythagoras theorem, AC squared is going to be equal to AB squared, which is A squared, plus BC squared, which is also A squared. That's going to be equal to 2A squared. Taking square roots on both sides, AC squared is equal to 2A squared. Take square roots on both sides, AC will be equal to A square root 2. So AC is going to be A square root 2. Since now we know all the three sides of the triangle, we can easily figure out what are the trigonometric ratios. Let us find that out. Can we figure out what is sine 45 degrees? What is the ratio of sine? It is opposite side divided by the hypotenuse. So sine 45 is going to be equal to BC over the hypotenuse AC. And we know BC is A and AC is A root 2. A cancels and we are left with 1 over root 2. What is the trigonometric ratio of cosine 45? It is adjacent side over the hypotenuse. And we know what's adjacent side. We know what's the hypotenuse. Plug it in and we get 1 over root 2. What will be tan 45? It is opposite side over the adjacent side. So we figure out it's A over A, that's going to be 1. So we know what's sine 45 degrees. It is 1 over root 2. What is cosine 45 degrees? It's 1 over root 2 again. What is tan 45 degrees? It is 1. Can you guess what will be the cosecant 45, secant 45 and cot 45 degrees? So we know that cosecant is nothing but the reciprocal of sine. So cosecant 45 will be 1 over sine 45. If sine 45 is 1 over root 2, cosecant will be root 2 over 1, which is same as root 2. What is the reciprocal of cosine? It is secant. So secant 45 will also be root 2, the reciprocal of cosine. What is the reciprocal of tan? It is cot. So if tan 45 is 1, reciprocal of this will also be 1. So cot 45 degrees is also going to be 1. So we know what are the trigonometric ratios for 45 degree angle. Now let us move on to other specific angles. Let's figure out what are the trigonometric ratios of 30 degrees and 60 degrees. Let us consider an equilateral triangle ABC. What is an equilateral triangle? An equilateral triangle is a triangle in which all the sides are equal to each other. What will be the angles of an equilateral triangle? Each will be 60 degrees. So angle B will be 60, C will be 60 and angle A complete. That's going to be 60 degrees. Let us draw a line AD perpendicular to BC. And we know from our lower grades that if we draw a line AD perpendicular to BC, these two sides BD will be equal to DC. Let's consider AB to be of length 2A. Since it's an equilateral triangle, BC will also be 2A. Therefore, BD will only be half of BC, which is going to be A. Now, can we use Pythagoras theorem to find out AD? If we use Pythagoras theorem, AD will be A square root 3. Now, we know in triangle ABD, all the three sides, AB is 2A, BD is A, and AD is A root 3. Let us now figure out the trigonometric ratios. Let's figure out what is sine 30 degrees. Sine 30 is nothing but opposite over hypotenuse. The opposite is going to be BD and the hypotenuse is going to be AB. So, sine 30 degrees is BD over AB, which is A over 2A, which is equal to half. What is cosine 30? Cosine 30 is going to be adjacent over the hypotenuse, that is AD over AB, and that is going to be A root 3 over 2A, which is root 3 over 2. What is tan 30? It is opposite over adjacent, opposite over adjacent. So, tan 30 is going to be 1 over root 3. What will be the reciprocals of this? What will cosecant 30 be equal to? We can easily figure out. If sine 30 is half, cosecant 30 is going to be 2. If cosine 30 is root 3 over 2, secant 30 is going to be 2 over root 3. If tan 30 is 1 over root 3, cot 30 is going to be root 3 over 1. So, that is pretty easy to figure out. So, cosecant 30 is going to be 2. Secant 30 is going to be 2 over root 3. Tan 30, cot 30 is going to be root 3. So, we know what are the trigonometric ratios of sine, cosine, tan, cosecant, secant, cot for 30 degrees. From the same triangle, can you figure out what will be the trigonometric ratios of sine 60 degrees? Now look, the sides will change. What is the opposite of sine 60? Opposite side is going to be AD over AB. Can you figure that out? You can pause the video, figure out all the trigonometric ratios for sine, cosine, tan 60 degrees. Can you do that? Great going. Give a try. Okay, I am displaying the answers for sine 60. It is opposite over hypotenuse, AD over AB, and that's going to be root 3 over 2. Did you get that? Cosine 60, it's going to be half, and tan 60 is going to be root 3. Tan 60, we can put it over here, tan 60 is root 3. What about cosecant 60? It's going to be the reciprocal of sine, which is 2 over root 3. What about cosine 60? It's the reciprocal of cosine, secant 60, reciprocal of cosine, that's going to be 2. Reciprocal of tan is cot, and that's going to be 1 over root 3. So, you can just ignore this part of it, this part, because it's over here. Great. That was a good try from you for finding out the trigonometric ratios of 60 degrees. So, now we know what are the trigonometric ratios for 45 degree angles, 30 degree angles, and 60 degree angles. Let us find out what are the trigonometric ratios for 0 degrees and 90 degrees. In order to figure out what are the trigonometric ratios for 0 degrees, let us consider the triangle ABC, and let's take angle A to be some angle. Let's go on reducing this angle A. Let's make it smaller and smaller until it becomes 0. So what will happen? If you observe, when angle A becomes smaller, the BC starts reducing. As angle A becomes smaller and smaller, goes closer to 0, the length BC is also decreasing. And finally, when angle A becomes 0, the BC has also become 0 and AC becomes equal to AB. So now we can figure out what is sine of angle A. Sine is nothing but opposite over the hypotenuse, BC over AC. But when angle A is 0, BC is 0. So what will be sine BC over AC? It will be 0 over AC, and anything 0 divided by anything is 0. So sine 0 degrees is equal to 0. Can you guess what is going to be cosine 0 degrees? Cosine A over here is 0, is adjacent over hypotenuse. Adjacent side is AB, hypotenuse is AC. When angle A is 0, both happen to be of equal length. So cosine A, when angle A is 0, AB over AC. AB is equal to AC when angle A becomes 0. So cosine 0 is going to be equal to 1. Once when we know sine and cosine, we can easily figure out what is tan, because tan is sine over cosine. So what is tan 0 degrees going to be? It is going to be sine 0 over cosine 0, which is going to be 0 over 1, which is 0. What will cosecant 0 degrees be? It will be the reciprocal of sine. What is the reciprocal of sine? It's going to be undefined. Why? Because 1 divided by 0 is undefined. What about the reciprocal of cosine, which is secant? That's going to be 1. Reciprocal of tan, which is cot, that's going to be also not defined, because tan 0 is 0 and the reciprocal of 0 is not defined. So we know what are the trigonometric ratios of 0 degrees. Let us figure out what will be the trigonometric ratios of 90 degrees. So in figuring out the trigonometric ratios of 90 degrees, let's consider the triangle ABC, and let us start increasing the angle A until it becomes 90 degrees. So how will the triangle look like, the transitions? Now if you observe over here, when angle A starts getting increased, AB is getting smaller and smaller. And when angle A becomes 90 degrees, AB becomes 0 and AC will be equal to BC. Now can you figure out what is sine 90? Sine is nothing but BC over AC. Now in this case, when A is 90 degrees, BC and AC are equal. So sine 90 is going to be equal to 1. Can you guess what is cosine 90 going to be equal to? Cosine is adjacent over hypotenuse. Cosine 90 adjacent AB. AB has become 0 and hypotenuse is AC. So 0 divided by anything. Good guess. Cosine 90 is going to be equal to 0. Once we know sine and cosine, I leave it to you to figure out the rest of the trigonometric ratios. So pause the video, go ahead, and then later we will summarize all these specific angles in the form of a table. These angles are very important, the values of this, so that we will be using them directly in the problems that we will be solving. So go ahead and figure out what are the other trigonometric ratios for 90 degrees. So here is the summary of all the angles for the trigonometric ratios. Sine 0 is 0, sine 30 is half, sine 45 is 1 over root 2, sine 60 is root 3 over 2, sine 90 is 1. Cosine of 0 is 1, cosine 30 is root 3 over 2, cosine 45 is 1 over root 2, cosine 60 is half, and cosine 90 is 0. Do you observe something? When the angle increases from 0 to 90 degrees, the sine of the angle increases from 0 to 1, and the cosine of the angle decreases from 1 to 0. Just keep that in mind. And tan 0 is 0, tan 30 is 1 over root 3, tan 45 is 1, tan 60 is root 3, and tan 90 is not defined. You must have figured that out from the previous slide. Cosecant 0 is not defined, cosecant 30 is 2, cosecant 45 is root 2, cosecant 60 is 2 over root 3, cosecant 90 is 1. Secant 0 is 1, secant 30 is 2 over root 3, secant 45 is root 2, secant 60 is 2, and secant 90 is not defined. Cot 0 is not defined, cot 30 is root 3, cot 45 is 1, cot 60 is 1 over root 3, and cot 90 is 0. We know how we came up with all these angles. Keep this table in mind. You can take a printout of this and keep it at the side while you're working out the problems until you know them from your memory. Based upon these values, let us try to solve some of the problems. Let's try this. In triangle ABC, right angled at B, AB is equal to 5 centimeters and angle ACB is equal to 30 degrees. Determine the lengths of the sides BC and AC. Let us, for the ease of working out in problems, let us label them with variables. BC as side X and BC as side X and AC as Y. Now from the angle C is 30 degrees. If we have to find X, from angle C, this is opposite and this is adjacent. So which ratio can I use? Opposite over adjacent. Which ratio? It's tan. So can I say tan 30 degrees is equal to opposite over adjacent? Opposite is 5 centimeters over adjacent, which is X. How much is tan 30? What is the value of tan 30? It's 1 over root 3. So 1 over root 3 is equal to 5 over X. Cross multiply, X is going to be equal to 5 root 3 centimeters, and X is nothing but BC. So we have found what BC is. Similarly, can we find what is AC? From 30 degrees, AC, this is opposite over hypotenuse. Which ratio can I use? Opposite over hypotenuse. I can use sine. So sine 30 degrees is equal to opposite, which is 5, over hypotenuse, which is y. How much is sine 30? It is half. So half equal to 5 over y. Cross multiply, y is going to be equal to 10 centimeters. That is nothing but AC. So we found out what BC is and what AC is as per the question that was asking us. So great. You need to remember what these trigonometric ratio values are in order to solve these type of problems, and figure out what's given and what you need to find out, and choose the appropriate trigonometric ratio to apply. Let us work out on some more problems. Let's try this. In the triangle PQR, right angled at Q, PQ is 3 centimeters, PR is 6 centimeters. Determine angle QPR and angle PRQ. So let us look at angle R from here. Angle R. Let's consider angle R. From angle R, which is the opposite side? 3 centimeters. Which is the hypotenuse? 6 centimeters. So we know opposite, we know the hypotenuse. Opposite over hypotenuse. Which ratio? Sine. So can I write sine R is equal to opposite over hypotenuse? Opposite is 3, hypotenuse is 6. So sine R is half. For what angle of sine is the value half? It is when R is equal to 30 degrees, because we know that sine 30 degrees is equal to half. We know that. So angle PRQ, angle PRQ is 30 degrees. So if this is 30 degrees and angle Q is 90 degrees, what is angle QPR? It's going to be 60 degrees. We don't even have to do any trigonometric ratio for that. So angle QPR is going to be equal to 60 degrees. So figured it out. Great. Keep working, keep trying. Let's work out one more. Let's try this out. If sine A minus B is equal to half and cosine A plus B is equal to half, and A plus B is between 0 and 90 degrees, and A is greater than B, find A and B. Very simple. If sine A minus B is equal to half, sine A minus B is equal to half. For which angle of sine is the value half? For 30 degrees, because sine 30 degrees is half. So A minus B then is 30, isn't it? A minus B is equal to 30 degrees. Let's look at cosine A plus B. For which angle of cosine is the value equal to half? When A plus B is going to be 60, because cosine 60 degrees is half. So A plus B is equal to 60. So we know A minus B is 30, A plus B is 60. Let us label these two as equation 1 and equation 2. Now we have moved on to our level, grade 9 level, solving problems. A minus B is 30 and A plus B is 60. Can you solve them? So A minus B is equal to 30, A plus B is equal to 60 degrees, solved by elimination method. So cancels. 2A is equal to 90 degrees. Therefore, A is going to be equal to 45 degrees. If A is 45 degrees, what will B equal to? If A plus B is 60 and A is 45, so B is going to be 15 degrees. And since A is greater than B, so we have figured out A is 45 degrees and B is 15 degrees. Excellent work. appreciate your concentration and focus on understanding the concepts of the lesson. The only thing is, keep in mind the different values of these specific trigonometric ratios, because you will be using these specific trigonometric ratios, the values of these, in the forthcoming problems too. So you need to be really thorough in the values of these trigonometric ratios. Look at the table and keep the table handy in your mind. Thank you for watching this video. Please share and subscribe. Thank you.